Hi everyone, in this video we'll be having a look at Hooke's law and try to understand all the points of the stress strain curve. Stress strain curve. This is what a normal ductile material looks like. Just down there. This is a ductile material, and on the y-axis we have stress, and the y-axis we have x-axis, we have strain. It's always like this. Stress is always on y and strain is always on x. And let's take these points A, B, C, and D. Now you guys may be assuming what are these points? Well, point B is breaking point. My bad, this is elastic limit. C is UTS, and UTS stands for ultimate tensile strength. And D is breaking point. As the name suggests, the material or sample breaks at this point, and this point has the longest elongation. As you can see from here, this is elongation. Right? Because x-axis we have elongation, so if we draw a line down there, this is the max. So as the name suggests, elastic limit is the limit where the elastic region, by the way, this is the elastic region of this curve. Elastic region. And once the force exceeds this region, or the material exceeds, the stress in the material exceeds this region, it reaches in plastic region. This whole thing is plastic region. In elastic region, the force applied on a sample, if the force is removed from the sample, the sample can return back to its original shape. It won't be deformed permanently. It will be temporarily deformed, but it will come back to its original shape. Whereas in the plastic region, once the force in plastic, force removed, but the deformation is permanent. It won't go away until the breaking point. The sample will keep deforming, and at D, the point D, it will break down. And the material in which we have elastic and plastic ranges, we call these material ductile materials. There is a point here also, yield point. This is stress at yield. We will have a look at this yield in a separate video because this is a major topic in this stress strain curve. But we'll currently focus on these points B, C, and D. This is UTS. So wherever the UTS intersects this y-axis, this is sigma UTS, this point. Let's call this point E. So E is sigma UTS, that is the stress in UTS, stress at point UTS. So bulk modulus E is equals to, E is not this point, this not E, E is a separate point, separate thing. Bulk modulus or modulus of elasticity. Bulk modulus or modulus of elasticity. So the formula for this bulk modulus is delta stress over delta elongation. So stress is force time divided by area, and elongation is unitless because elongation is simply change in length, change in length divided by original length, length initial. So the units are Newton by meter squared or pascals. And another thing to keep in mind is sometimes we are given force by elongation and the curve looks same because let's see how. Same, this is the elastic region, elastic in the force and elongation curve, and this is plastic. Every point is same. This is C, this is B, this is D. The only difference is this point is force at UTS. This is not equal to stress at UTS. Please keep in mind that stress is force time divided by area. So whichever force you will get here, if you divide it by area, you will get the stress at that point. If you divide this point by area, you'll get the same value as this point that we took here. I hope you understand. Thank you for watching this video. I'll see you in the next video about yield.